So here we are. I just noticed that I didn't even start a stream, so that's a very good thing, of course. Here we are. So what's this gonna be about today? What's it gonna be about? I want to make a thing, a viewer, or basically a desktop application that can like view the Mandelbrot set or any set. In fact, I just explained this on my own, so yeah. That can like pan through and zoom in and stuff for basically any set or any equation, yeah, get to do that. I always wanted to do that, and I think the Mandelbrot set is a good thing because I can see if it works. I have no clue how I'm gonna implement it, but I will find out. And for that, I'm going to use Kotlin and IntelliJ IDEA, which I'm just setting up right now. Oh no. Yeah. Send these statistics. Whatever. I want to get a new project. And I want to work with Kotlin for the JVM and with Swing, because I kind of know the components there. Not really, but kind of. And that the stream seems to be working. And it seems to not be laggy, is it? I need to test that out. Well, it's really, really blurry. Some reason. Can I like view it in here? Is there any way to view this? Apparently there's not. My channel. Show me. Okay, it's kind of blurry, but not that much. It's alright, it's alright. Okay. Oh no, I closed it down. Please give it back. Yeah, mute that thing and let it run in the background so I can watch it when I need it again. Okay, so let's go. Kotlin JVM should be fine. Next. Project with no SDK assigned. Do I not have a Java SDK? No, apparently not. Download JDK. Open JDK. Wow, it's starting to rain real bad. Damn. So, once we have that going, I think we can just get right into it. Let's do this. Okay, so the thing is, as I might have said, I know the Swing library a bit, so I'm trying to work from that. Mandelbrot viewer. That's not a good location. Let's go here, code. Okay. Code / Mandelbrot viewer. Project directory does not exist. It will be created. Yes, please do that. Okay, now first of all, let's get some settings right. I need to, well, get me a project. Okay, it's gonna first of all index the JDK and shit. Yeah. But still my font size will be too low, pretty sure. And that's probably still too low. JetBrains Mono, that's a good font. For code I like better. 22. I'm not sure, is that readable? I guess so. Yes. Okay, let's keep it at that. Okay, is it done? Yes, it's done with indexing. So I'm gonna go ahead and create my first class. So for a second I need to okay, then maybe not. Okay, well, I tend to call my main classes either just main or the project name, so I guess we'll do that. Classes are capitalized, so Mandelbrot, viewer, and camel case. Okay, so can you see that on the screen? I guess so. Yes, you can. So now I'll make that smaller and I will go into presentation mode. Where is it? It's always been here. Here, presentation mode. Okay, that's really not that good. Enter full screen. Exit presentation mode. Enter full screen mode. That's better. Okay, now, first of all, we need some kind of window. Which is gonna be a JFrame. So why did I create a Java class? That was stupid. Did I create a Java project? No, right? I created a Kotlin project. Class. Mandelbrot viewer. Okay. Now we can select a new version. Well, I don't need that right now. So I hope the version that's coming with the IDE is all right. So let's go. First of all, we need a constructor init. And we'll get a main method. New Mandelbrot viewer. We don't need view here. Mandelbrot viewer. Okay. I'm not really into watching the lifetime things right now, so I'll get into that later. Okay. Once we do that, first of all, I want to JFrame val window. It's a JFrame, so window equals JFrame. Okay. And here it could be private. Yes, it should be private. Oh, that's not what I wanted to do. I actually wanted to make it private. So it's saying now can be joined with assignment. Yes, it could be. Into that viewer, what I want to do is, well, I want to show a canvas. First of all, let's look up how a canvas works in Java. Swing canvas. Let's look it all up. So we don't have a canvas, we can get a JPanel, okay. Implement your own way of painting it. Yes, that's what we need to do. So the thing is, once I get a JPanel, it can be resized whatever I pull my window. So let's try that out. Window.root pane is Or is it set root? Sizable. No, add. Okay, I guess we'll add a. I'm just gonna save it as a property for now. Not sure if I'm gonna need it. Yeah, Root Pane, which is a jpanel. Please import that. Okay. So Root Pane is jpanel. I might have to get some class hierarchy for that later. So we'll first add the Root Pane. I might want to get a new class right now. But for now, can we get Root Pane dot LUI, whatever. Okay, I'll get a new class going. Mandelbrot canvas, or let's not call it Mandelbrot, let's just call it canvas, maybe, because as I said, I want to make it pretty generic. Well, maybe then Mandelbrot viewer is not the best name, I guess. We'll stick with it for now. Just let's not include Mandelbrot anymore anywhere. So the canvas class is extends the jpanel class and the jpanel. Okay, does that not work? Oh, well, I guess. Okay, so we extend the jpanel, then we alt insert, implement override methods. We want to get draw. No. It's called paint. Paint immediately. Paint all. Repaint. No. That's paint components. I'm pretty sure I don't think it matters because I'm just not putting any components in there. So yeah, well, that's not really what you should do, but I don't have a choice here. So I guess that's what I'm gonna have to do. So is the video buffering anything? It doesn't seem to be. Okay. So first of all, we do the normal painting stuff, and then we go with the draw something, please. Draw from 10 to 20. Is that gonna work? Well, of course it's not gonna work yet. What's the problem here? Oh, it might not get, yeah, so okay. Why is it only maybe? Oh, because that. Can I move that? Well, I'm pretty sure there is going to be a graphics input, so I'll just go with it. And we don't want that to be a jpanel. We want that to be a canvas. Be a canvas, please. So. This can still be joined with the assignment. This should also be able to, right? Maybe. Okay. Well, first of all, let's try it out. Application, Java runtime. Can I not just click function main? Run? Might be able to. So now I don't know if the full screen mode is gonna actually work. Nope. So something crashed. JFrame. But it finished with code 0, so I'm not sure. Oh. I need to set the window to visible. I'm pretty sure there's some like weird quirks in Java about that. Oh, yeah, I didn't set a size. Window size is, I think I can do a tuple like that. I'm not sure though. 600 by 600 is always good. It's probably, well, what does it expect? A dimension. Dimension. Okay. Let's retry. Yeah, so it's working. I can resize that. Draw an outside. Well, seems to work perfectly. Exactly as I want. So, what's next? What's next? So we got a window. I think I want to get these out into variables, maybe. But maybe not right now. I think that's gonna be better to do when we get to yeah, well, let's not do it right now. I don't know what the signature for the Mandelbrot viewer should be, so I'm just gonna leave it like this for now. Okay. Now, can we get this dot size? Can we print this? Print line on every repaint. That's gonna be a lot of repaints. Oh, yeah, right. So the thing is, as you can see, right in the top right here, the application isn't stopping correctly once I close the window. That is because, first of all, let me remove this. The window needs to be needs to get its action. Yeah, default close operation is exit on close. Exit close. Oh, so what class does this expect? JFrame dot exit on close. There it is. Great. So now when we start it, it should first of all give me the size once it repaints. So okay, we are getting the correct size. Perfect. That's great. Okay, that's all we need basically. So we need to do some trickery. We need to save the current position of our of the view we have. Well, maybe let's first get into the cool stuff, the drawing. So let me look up how the Mandelbrot set actually works. Yeah, that's the cool looking thing I'm talking about. So it's something to do with complex numbers, and if some equation is correct, then it's yeah. So this is what I want to get basically. First of all, let's go to get black and white. Okay, so first of all, let me get this in English. I'm not even sure why it's showing in German. Well, okay, the Mandelbrot set. Static number of iterations per pixel. Okay. Looks real cool. Basic properties. The Mandelbrot set is formal definition. That's, I think, what we want. So, set of values C, the complex plane, for which the orbit of the critical point Z on the iteration, blah, 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 blah. C. Z remains bounded for all n bigger 0. So, unfortunately, I'm not that good at reading this stuff. So, what I was thinking is, like, I see all those pixels. So on every redraw, I want to go ahead and for each pixel calculate the value of that place in the coordinate system. So we need an external coordinate system first. That's really important. But I'm really interested in how I'm gonna do this. So which tends to infinity. So oh man. So this looks good. This looks like code, but it's for something. No. Computer drawings. Where is plotting the computing device? Okay. Yes, that seems accurate. That seems like the thing I want. So the result of each iteration is used as the starting values for the next. Values are checked during each iteration to see whether they have reached a critical escape condition or bailout. If that condition is reached, the calculation is stopped. The pixel is drawn and the next XY point is examined. Okay. So this is this basic algorithm for doing the Mandelbrot set. So let's just copy that and convert it to Kotlin. Well, no, not quite actually, because I need to get this a little bit more abstract. So first of all, I want to get a functional value. So, well, current function, because there should be something in here. Yeah, this thing. So the call. Yeah, I don't think you can even see it. I need to scroll in a little bit more. I'm sorry. So for each pixel, we do something. So this is part of the outside thing. And we need to assign the color. This color comes from some kind of algorithm, so palette at iteration. Palette is defined somewhere else. So, okay. So this whole thing goes into the Mandelbrot thing. Okay. So first of all, I want to create a new Kotlin class, which is the function definition or something. Let's call it set definition. I guess. So this thing goes like this. Okay. You can instantiate it just without parameters, and then we get a function public. This gets an x and a y value. Which is both gonna be a... Oh, what's it gonna be? Am I just gonna go with a float, or am I gonna go with a big decimal or something? I guess for better scrolling I should go with a big decimal. I'm not really sure. So let's just go with it. Big decimal. And we of course need a function name. Public function get color 4 point. That's not really a good name, but it will suffice. So then we have another coordinate, which is also a big decimal. And this can be abstract. Oh, it does not like that. Okay, yes, because this needs to be an abstract class. So, okay. Now, let me organize this a bit. So get a new package, which is set definitions. Put that in there. Okay, refactor it. And then we go, no, not a Java class, a Kotlin class. So we're gonna go ahead and put in the, what kind of set am I gonna put in? The Mandelbrot set, of course. Mandelbrot set definition. Okay, so let's implement methods. Oh, yeah, of course, I need to set definition. And implement. Okay, not yet implemented. That is correct. So I'm gonna look at the algorithm again, and then I'm just gonna paste it into here. Okay, so this is of course not gonna work. X0, Y0, scaled X coordinate of the pixel, scaled to lie in the Mandelbrot X scale. Okay, so there's a maximum to how far we can zoom out, apparently. Should there be? I don't think so. Okay. Well, we're gonna see how that works out. So these two are just gonna be, so now what is this looking for, this code? It's doing something with the X and the Y. Okay, where is Y0 used? Y0 is used later. Okay. Okay. I guess these will be these two. So then we have some other Y, which I don't know, called X1 and Y1, and just rename everything in here. Not even sure what it does, but we'll see. X1, Y1, Here's even an xtemp. So val xtemp, we'll just rewrite it. And these are also values, if I could write. No message in chat, so we'll go on. Val iteration 0. Okay. Constant. Okay, not applicable to local variable, whatever. Okay. Well, something do. Here we just need parentheses around all of this. It's gonna get indented correctly. This needs to be an X. Okay. So I think we can, well, so to say, clean this up a bit. First of all, we do this. We increase the operation. So iteration needs to be a variable, of course. We need to reassign it. And these two also need to be variables. And this needs to be y1 and x1. So what's wrong now? This needs to be an and. And why is there 2 by 2? That has something to do with the thing, right? 2 by 2, okay. Not sure where that comes from, so let me read that paragraph about it again. Okay, here it says, to render such an image, the region of the complex plane where continues subdivided into a certain number of pixels. Yes, that's true. The color in such pixel, the midpoint of the pixel. I don't think it matters to be the midpoint, but well. You know, where the orbit point has modulus larger than 2. In this is the case, we know that C does not belong to the Mandelbrot set. We color our pixel according to the number of iterations used to find out. Otherwise, we keep iterating up to a fixed number of steps, after which we decide our parameter is probably in the Mandelbrot set, or at least very close to it, and color the pixel black. Okay. So, I'm not sure where this is coming from still, but we'll probably be fine. So, we're just gonna go with it. And so what's the problem now? Found double required boolean. Okay, I think I need to add some parentheses maybe. Get some here and here. Now this should be, oh yeah, this is of course not a sign. Less than or equals. Why are you underlined? So here's a colon too much. Is that a real plus or is it something different? Oh yeah, right. Okay. So we need a new big decimal. Oh boy, this is gonna get funky, and it'll probably be really slow. But we need this to be a big decimal of 0. And this should be 1 as well. This can be a integer, I guess. So should not contain underscores. Yes. Guess that's correct. Max iteration. Okay. So that's original. So let's get big decimal. Do we have a big decimal 2? No. Big decimal of 2, maybe? Yes, times that plus that. Yes, it's a big decimal, so that seems to work. We can just big decimal of 4 that thing. Okay. I should really get that out of there because the compiler might not do that. Well, let's just leave it in. But generally you want to avoid some new object creation inside of a loop variable, so just be wary if you do this. It might end up badly. Might not end up the way you want it. So someone called me, not sure why or where they got my number from, but let me just look at this real quick. Okay, guess it'll be all right. So okay, so this is also inside the loop, which is not really good. I might make a class for that to create these constants. But yeah, might also work. Well, no. I need to take this out because this is a reference type and it's gonna get recreated pretty definitely. So let me make a new package which I'll call util, and then I make a Kotlin class which I'll call big decimals or big decimal constants. Okay, and we'll make a, let's make it an object because it's going to be static, and we will get it public val. Oh, it's always public. Okay, big decimal of 2, and we'll call it 2. Then we'll get one for 4. So for anyone that doesn't know why I'm doing this, it's because the compiler will not, at least very likely not, be smart enough to take this out and make it a constant, but we don't need to recreate a new big decimal with value of 2 every time. You can just like go ahead. These are immutable anyway, so we go big decimal constants dot 2, and here we go big decimal constants 4. Okay, that seems to be good. Okay. Now we have the iterations. Now we need to map this to a color. So I would say I'll first of all just like take any brightness for it. So no, we need to first of all go to set definition and make it have a return value color from AWT. Package name should not serve an uppercase letter, whatever. we'll go ahead and implement that. No. We can move that. So for the Mandelbrot set definition, we'll go ahead and return a color, and we will return, which is also really not good to have our color like that. Because every time this is gonna get called for every pixel every time it gets repainted. So if we resize it, it's gonna get repainted. It's gonna like create a new color object. Well, let's just go with it. Or otherwise we're never gonna get done with it. So return a new, no, we don't use new in Kotlin. Color, what you're gonna get is an integer or a float. So we're gonna go ahead and take the float, and we're gonna do this and this. Just gonna go ahead and say, so we want 1 minus the iteration, the current iteration, divided by the max amount of iterations. And I can just make iteration a integer, it will still work. Okay, and we will do that for all of them. So in this code there's, and we'll take full alpha if that's a requirement. Float. Nope. Float. Should be a float, right? One float. Okay. Yeah, sure. Still not happy. Because this is still not a float. Yeah, okay. Now we're cooking. Go ahead and do that. Okay. That should maybe work, right? And I'll just... Now I need to map those coordinates into our new coordinate system. Okay, so we have a variable v, which is also private. X, y, no, which is gonna be. So how are we gonna do this? I guess I'm not sure. So what do I want to do? Okay, we need an X, we need a Y, we need a width, we need a height. That would be a rectangle. A rectangle is a value type, so I don't really want to use that. Like, if I can get around it. Or no, it's not a value type because we're in Java, so it is actually a immutable reference type. which is really bad, which is the worst thing you could have. So let's, I'll just keep it in like this. So 0, y. These probably need to be big decimals later, so I think I'm gonna have to put all of that into the canvas. So canvas is probably the wrong name for it, but let's see.
Hey, yo, Noir.
View X. Sounds good, right? View Y, because we're talking about our internal coordinate system, right? So okay, we don't need to draw the line. We don't need to print the size. We just want to get a set definition in here. Set equals of type, we don't actually need to put that in a set definition, equals Mandelbrot set definition. Let's instantiate that, and then we go with set dot get color for point, and for painting we need to go ahead and need to draw on every point. So for Kotlin is so weird when doing for index for loops. So let me look it up. Indexed for loop. Indexed for with index, which is an array thing. No. So, okay. For I in 0 to until, because we don't want to include the last thing. Size dot. We want to go through every x first, so we need to go through the height first in the code. So now we go ahead and go for j in, oh, let me get j on the outside and I on the inside. Okay, 0 until size dot width. Okay, and we go ahead and, which is also really not good practice, because we could probably do some interpolation and draw bigger like rectangles, which is way more efficient because it can be done by a graphics card and stuff. We're just gonna go ahead and go g dot draw point set color. Okay, no, dot point. Something. In the worst case, I can draw a rectangle with a single point, but I would have loved to like just draw one vertex in a maybe more efficient way. Okay, that's not gonna work. Okay, fill rect. We go I, J, and size dot width. No. 1. Just want a single point, and now I just remembered how we gotta put this in. That's why there's a set color method on the graphics. Set color is get color for point. And then we go IJ, but we need to scale it, so that's really not gonna work. Okay, for the first test, I guess we can say the one. Oh yeah, right. It goes from -2 or something. It was in the Wikipedia article, so yeah, it goes from -2.5 to 1 and from -1 to 1. So let's scale that. Okay. Okay. We need to scale it to a value between something. There's probably a library function for this, but go ahead and just get I divided by the size dot width, which I need to be a float, but we'll fix that later. And then we will multiply it by something. To float, please. And we multiply it with like 3.5, which is by 3.5 float, and we subtract 2.5 float from it. And then we go ahead and do big decimal and wrap that thing in. I mean, the big decimal is not needed right now, but we're gonna need it later. And then we're gonna do a similar thing for j, big decimal of j divided by size, height to float, and multiply that with 2, and then subtract 1. And it does not like that because we want to float in everything, right? No. You gotta be kidding me. Why does it not take a float? Takes everything but a float. Okay. Let me get in a double. 2 double. 2 double. And remove the float signs. So yes, now it's happy. Okay. I'm really skeptical. Really skeptical. But we're gonna see. So we have the canvas in there. The canvas is gonna do that on painting. And we're gonna get an error. I can almost feel it. Okay, it's doing something. This is going to be really hard to debug. And it does not like doing that many calculations, apparently. Okay, unresponsive. All right. What is the problem? Oh, yeah, right. Okay. Huh. Now I might need to understand the algorithm, which is not ideal. So first of all, let me look up why there's a 2 in here. Why is there a 2 in here? Does that have something to do with the scaling stuff? Because these should be scaled, right? These should be perfectly scaled to be inside this thing. Okay, well, let me real quick add a workaround. Return color. Let's see if it does anything. X to int modulo 255 0. Okay, I should be able to run this, right? No, does not like it. Color parameter outside of range. Yeah, you're outside of range. Why would you be? X to int modulo 255. Oh, because it might be negative. Let's just like go for 255 plus. Okay. Not that much of a gradient, I'd say. Like we should not get nothing less than -2.5, so 3 plus something. And let's also take the blue, the UI value, so we should get a nice gradient. Wait, what was that? Y dot to int 1 plus y dot to int modulo 255. Oh yeah, right. I think I know why we don't get a gradient. I think I might know. Yeah, that redrawing is taking a long time. I might need to like go ahead and multi-thread this. So let's go ahead and just go 2 times 3 plus 30 times this value. Let's go for a 100 here. Should still all be in range. So nope. Call out subparameter. Expecting something different. Maybe we need to put in parentheses. Oh boy, we're not getting very far. Kill that, run it again. It would be really nice. Create a breakpoint there, please. And debug that. Yes, allow it access. Okay, R is -57. Well, yeah, of course, because it's taking the thing first. Oh, I might have left a breakpoint in some piece of code that I don't know. That's not good. Okay, yeah, of course we need to First apply this and then go ahead and 30 times that. Otherwise we're gonna get garbage. Okay, this is looking at least a little bit promising, even though the y value is not really changing. At least it works in theory, so there is actually something wrong with the other code. Okay, once I redraw that should really stretch out. Yes, it does. Okay, so redrawing still really slow, which is not making me really comfortable, but at least it works. Okay, so the mistake has to be in here somewhere. Or is it 1 minus iteration divided by max iteration? So some iteration, this might be less than, and then it gets to 1,000 and it breaks. Okay, so it should not be more than that. Maybe it was just calculating that long? I don't know, maybe. Let's wait for it. We might be in for a treat. So let me get the performance monitor up. So yeah, we got like few threads which are it seems to be getting rescheduled every now and then, but where is it? Very high, 5% CPU. Okay, it's not going anywhere though. So this seems to be too slow, which is not ideal. Am I really gonna have to like split it and multi-thread it? I'm not that happy about that. Come on, show me a picture, please. Okay, now I'm gonna go ahead and stop this, and I'm gonna just print. Oh no, to get that moved in here, and print line the X and the Y. So we, oh no, that should really not be in here. So we can see to int, no, to string, better. No, we do template strings in Kotlin. Right. Kotlin template string. How is it done? Basic syntax. We go ahead and put $1 before it. Right. $1 here. $1 there. I really need to close it again. Is that gonna work? I think it might. Okay, let's try it out. Okay. Oh yeah, we're getting the scaled values. Stop it, please. Stop. Stop. I want the unscaled values. So when you're done print me the X and the Y, or the I and the J, please. Okay, so we can see some take longer. All right. So this is really slow, and I'm not sure if it's because of the big decimals, but I would guess so. Like, look at this. We're not moving, and this is like a really beefy processor, so... Well, not single-threaded beefy, but... Did it get stuck? Did it just get stuck? Or are we getting like really, really, really big or small decimals? How is the RAM doing? Memory. Where is Java? There it is. Memory, 1.2 gigabytes. So it's not going up, not going down. It's moving at least. So it's probably gonna have to wait for each GC cycle. So that's not good. Can we get the 414, please? Please. Okay, so let's go ahead and stop that and remove every little bit that uses big decimals. Okay, we're just gonna use doubles. Get color for point. It's gonna take a double. And it should be okay. No, this needs to get doubles. Okay, so we have a 4.0, oh no, 0.0, 0.0. We don't want a float, we want this to be a double. And then we need this to be a 4.0 maybe. We actually don't need it, but it doesn't matter. We have floating point processors. Here we multiply, so we can leave that. And we can leave that, so we might get a little tiny bit faster. And now we need to okay, so outside of the range, no. We need floats, so this is an int, this is a double. We'll just make this a float. How about that? It doesn't matter. Okay, so now this should go way faster, hopefully. Yes, and it does. Can we scale it though? Yes. Copy pasting code like a boss. Okay, now it's actually redrawing right now, so I might have to make it so it doesn't always repaint it, only when we like moved and then stand still for a second. Okay, so this is looking really, really promising. I'm gonna tell you, like, that's great. The detail, it's amazing. Okay, didn't think it would be that easy. Well, like that easy. We just copied from Wikipedia and this is what came out, so. Okay, now for the actual difficult part. The scaling and the moving around. So I didn't really understand the algorithm yet, so I might have to, like, where is this 4 coming from? I know it was 2 by 2, but that's like not really. not really happening. I think it said something about if it's a multiple of 2. I don't see that. Okay, that's an old browser. I don't need it anymore. Okay. Let me look at the thing again. At each step, whether the orbit point has a modulus larger than 2. Oh. Oh, I think I got it now. Okay. So, because I would really like it to have the ability to just go freely. I don't want any sort of constraint telling me to go between like 2.5 and 1 or -1 and 1. I just want to be able to pan around freely and zoom in, zoom out, whatever. So, how are we gonna do this? I don't think we need to touch the algorithm. That would be really interesting to see, actually. What if we change this to like a bigger thing? So we stretch it out twice the size, and then we go ahead and pull it -5. Is that how it needs to be? Should be, right? So we go this F4, this -2. So is it gonna be like twice the size now? Or like half the size? Not sure, but it sure looks like it. Okay, yeah, that's definitely smaller. So it does work. It does work. I can just plug in any value I want. Huh. Okay, interesting. Interesting. It's working. I like it. Okay, so we don't need the progress thing, right? I'm really interested in adding a progress bar thing sometimes, but yeah, let's first get it working correctly. Okay. Let's add panning. I have so much stuff I want to put in here. So first we go ahead. And now we okay, for optimize imports. So big decimals, not gonna happen. That's just way too slow. So I can just delete this. Yes, delete it. Okay. Already cleaned up a bit. Okay, can delete this. This is always public. No big decimals anymore. Okay. Now. Okay. First of all, okay. I want to add in a zoom factor. Var zoom factor, or just zoom. Zoom is 1. One float. Okay. Okay. Oh, now I just want some viewport magic. Okay. This zoom factor needs to be like something that makes sense. Or does it? Okay, let's just make it like this. Okay, we have a coordinate. And again, this all goes to the canvas. We have our view X and view Y, which we are not using yet. Okay. Now, once we okay. I'm not really sure how that zooming is gonna work. I really have to think about that. So we have an X and Y position of our like camera thingy. Then we have a X and Y coordinate from our global viewport thing. And these are going to be offset. Okay, so this is quite difficult to wrap my head around this because when we resize or pan, I want to like keep everything, just like move my view. Okay. Huh. That's gonna be really, really magical. Okay. So the point at which we draw. So this is gonna be the same. Okay. What if I just say here I plus view X and Y plus view Y? That's probably gonna end up in disaster, but we'll try it anyway. So okay, now we shift it down by like 60. Or let's go by 300 so we can really see it. So now if everything is just gonna work like this, it should be shifted down, but it's shifted up. Okay, well, what are you gonna do? Now if we go ahead and go for minus 300. Yes, so this is gonna push it down or up. And it's actually right in the middle. And then we can have, oh, now I know. Oh, this is gonna be good. This is gonna be good. Good. Also, like this scaling thing, this needs to go into the set thing. Or something, right? Is it? No, it does not even need to go in here. Okay. Let's get this out of here for now. And I want to push my thing to the left. Which means, first of all, I want to switch this to a negative. And push my thing to the left, which means I need to withdraw 300 from that. Okay, so now this should maybe show me something? No, apparently not. So what was I scaling? I was scaling this thing. Huh. Okay. I was scaling it by the total. I was basically mapping it into the space I want. I don't want to do that. I want to just have it the way it is. But if we just like scale it up by 2 for now, that should be like maybe do something. Should we see anything? Am I pushing it into the wrong direction? Ah, I was pushing it the wrong way. Okay, so we can actually see it. Yes, that's great. Okay. So now for the panning. That was surprisingly easy, I guess, if it works. Okay. Let's go for Java. Swing, mouse, move, mouse dragged. Mouse drag events. A mouse motion listener. Okay. Dance JPanel, mouse motion listener. You can probably not see anything. Okay. Mouse motion listener. So, and mouse motion listener. What's blank area? Like this documentation is like really weird. Registers for mouse events on blank area and panel. Ah, okay. So I need to add a mouse motion listener to, okay. This is like weird Java stuff. Adding yourself, okay. But I guess we'll do it. Mouse motion listener. Okay, implement those members, please. Yeah. Okay, mouse dragged, mouse moved. Oh, what does this mouse event tell me? Mouse dragged. Oh yeah, I want your cookies, please. Mouse event. Oh god. Okay. Mouse dragged. Yeah. Well, I guess we'll have to find out. Okay, yeah, mouse moved. First of all, we want to do nothing. We don't want it to do here because that's gonna crash. So, mouse dragged. Print line e dot. Expecting a mouse event here definitely, so I can do that. Okay, so now, oh, I didn't register it, so okay. JPanel. We need a init. Add mouse listener this, which is really cheesy. Mouse motion listener. Okay. Okay. So okay, I think that's good for now. We can go ahead and do some more another day. But it was a lot of fun, so I'm really looking forward to getting into this project more. Yeah, I hope you had fun also. So we'll see you again soon, I hope.